My dear students, in this video also I am going to solve some problems in differential equation, that is application problems of first order differential equation. Our first problem is, in the previous video we have solved some problems, application problems. The continuation of that, in this video also we are going to see some application problems. It is the first problem: the engine of a motor boat moving at 10 meters per second. The velocity of the motor boat is 10 meters per second is shut off. At the time of shut off, the velocity of the motor boat is 10 meters per second. Given that the retardation at any time equal to the velocity at that time. The retardation is equal to the velocity at that time. Find the velocity after 2 seconds of switching off the engine. After 2 seconds of switching off the engine, find the velocity of the motor boat. Whose velocity, the retardation of the boat is equal to the velocity. Retardation means opposite of acceleration. That is, acceleration, derivative of the velocity dv by dt is the velocity. But acceleration, velocity, derivative of velocity with respect to time is acceleration. But retardation is opposite of velocity. Therefore, minus dv by dt is equal to the velocity of the motor boat. It is given. Minus symbol indicates the retardation. Opposite of acceleration. Let's say it is minus dv by dt equal to v. From this, dv by v equal to minus dt. On separating variables, dv by v equal to minus dt. Now integrating both sides, you will get dv by v is log v equal to minus t plus integrating constant c. Now, raising the power of exponentiation, we get otherwise log v. The condition given is at time velocity is meter per second. When the motor boat is shut off, velocity is 10 meters per second. So at the time boat shutting off is time is 0 and the velocity is 10 meters per second given. Therefore, when time is 0, velocity is log 10 because v is log 10, log v log 10 minus time is 0 plus c. Therefore, c equal to log 10. That is, c equal to log 10. So the equation in C replaced by log 10, there is log V. Therefore, the motion of the particle log V equal to minus t plus log 10. C is log 10. Substituting value of C here, you will get log 10. That is, t, you bring it to the left hand side, t equal to log 10 minus log v. This log v goes to right hand side, it becomes minus log v, that is log m by n. Log 10 by v equal to t. Log 10 by v equal to t. Now e power t is equal to e power log is 1, therefore 10 by v. E power t is 10 by v. Now, our question is, find the velocity of the motor boat after 2 seconds of shutting off the engine. So, when time t equal to 2 seconds, find the velocity. And here, v equal to, 10 by e power t. So, if you put t equal to 2, you get v, velocity equal to 10 by e square. 10 by e square. This is the velocity of the motor boat after 2 seconds of shutting off the engine. This is the problem. Answer. Velocity after 2 seconds of shutting off the engine is 10 by e square meter per second. That's all about the answer of this problem. Over. This is the problem using application problem, finding the velocity of the motor boat. Next problem. the population growth problem. Find the population of the city at any time t. Second one. Find the population of the city at any time t. Find the population of a city find the population of a city at any time t. Find the population of a city at any time t, given that the rate of increase of population is proportional to the population at that instant. Given that the rate of increase of population is proportional to the population at that instant. Is proportional to the population at that instant. Population at that instant. It is the problem. Find the population of the city at any time t, given that the rate of increase of population is proportional to the population at that instant. And that is the population at that instant, and that is proportional to that is a period of, and that in a period of 40 years it increases from, and this population, and that in a period of 40 years, it increases from 3 lakhs to 4 lakhs. That is the problem. It increases from 3 lakhs to 4 lakhs. That is the question. Find the population of a city at any time t, given that the rate of increase of population is proportional to the population at that instant, and that in a period of 40 years it increases from 3 lakhs to 4 lakhs. After the period of 40 years, it increases from 3 lakhs to 4 lakhs. Then what is the population at that present instant? That is, we have to find out the population. It is given that the rate of increase of population is dp by the time dt. Let p be the population. Let p be the population at that instant. Let p be the population at that instant. Therefore, dp by dt is proportional to the population at that instant. That is, dp by dt equal to some constant times of p, because the constant of proportionality is k is the constant of proportionality. Now, from this dp by p equal to k into dt, integrating both sides, log p equal to kt, the internal dt is t plus c. So, population log p equal to k, integral t is dt is t. Now raising the power of exponentiation, you will get e power log p equal to e power kt plus c. This is e power kt and e power c. And this can be expressed as so p equal to e power kt into e power c. E power kt plus c can be expressed as e power kt into e power c. Okay. Now, initially the population is 3 lakhs and the time is 0. If the time initially the population is 3 lakhs and time is equal to 0, therefore you will get 3 lakhs equal to e power 0 into e power c. Okay? E power 0 is 1. Therefore, e power c equal to 3 lakhs only. So, you substitute this e power c value in the equation 1. Population is equal to e power c is 3 lakhs. E power c is 3 lakhs into e power kt. This is your equation 1. Population, the equation is e power c is 3 lakhs into e power kt, because e power c is 3 lakhs determined by using the condition time is 0. Now, after the increase of population from 3 lakhs to 4 lakhs, it is in 40 years. Therefore, when t equal to 40, p becomes 4 lakhs. That is, here you have 3 lakhs into e power k into time is 40. 40k. T equal to 40. At that time, p is, the population is 4 lakhs. Okay. So, substituting this condition, 4 lakhs by 3 lakhs is 4 by 3 equal to e power 40k. 4 by 3 equal to, because 4 lakhs by 3 lakhs, it will bring to the left hand side, it is 4 by 3, e power t is 40. Now this is e power k, the whole power 40. This is equal to e power k, the whole power 40 equal to 4 by 3. So from this expression I can replace e power kt is e power k, taking the 40th root on both sides. Listen, taking 40th root on both sides, you will get 4 by 3, the whole power 1 by 40, 40th root, 4 by 3 the whole power 1 by 40 equal to e power k. Okay? That's all. E power k value you know. In this equation, you replace this is your required equation. Therefore, the required population is from 2. From the equation 2, the required population is, the population is p equal to 3 lakhs into e power k is 4 by 3 whole power 1 by 40 into t, that is t by 40. 1 by 40 into t becomes e power k is replaced by 4 by 3, 1 by 40 into t is t by 40. So this is our required population. 3 lakhs into 4 by 3 power t by 40 is the required population of the That's all about this problem. Next, third problem, we are going to use a linear equation, application problem using linear differential equation. We will see one problem. These are the equations using variable separable method. The next application problem using linear differential equation. For that, you consider the problem, the third one. The equation of electromotive force for an electric current. The equation of electromotive force for an electric current. The equation of electromotive force for an electric current containing resistance and self-inductance. Containing resistance and self-inductance. Containing resistance and self-inductance is given by E equal to electromotive force is given by a relation E equal to Ri plus L into di by dt. This is the equation given by the electromotive force. R is the resistance and L is the self-inductance. E is electromotive force. It is given by the relation E equal to Ri plus L into di by dt. Okay. Where E is the electromotive force, R is the resistance and L is the inductance. Find the current I at the time. Problem is find the current I. Find the current I at time t when E electromotive force is 0. When E equal to 0. That's our problem. The electromotive force is given by E is a relation, resistance and self-inductance. Find out the current I at time t when electromotive force E is 0. Now you rewrite this equation into a linear form and then you have to solve the problem. These problems are very much used in current electricity. See, from this di by dt, L into di by dt plus Ri equal to E. You rewrite this as, and you divide throughout by L, you will get di by dt plus R by Li equal to E by L. So this is the form dy by dx equal to Py plus Py equal to Q form. Here P equal to R by L and Q equal to E by L. E is electromotive force, L is the self-inductance, R is the resistance. This is P is R by L. Therefore, now first step you have to integral y in the dy by dt, dy by dx, y is I. In the replacement y by I and x by t. Therefore, integral p dt. That's our requirement. Integral p is R by L dt. That is equal to R by L. You can take outer integral dt integral value is t. So this is now this is integral p dt is R by L into t. Now integrating factor e power integral p dt equal to e power r by L into t. So next, integrating factor is equal to e power integral p dt equal to e power r by L into t. This is raising the power of e power r by L into t. This is integrating factor. Therefore, the solution is I into integrating factor e power r by L t. I into e power L p dx integral q. Q is e by L into e power L p dx e power r by L t dt plus integrating factor c. Now I into e power r by L into t equal to, you can take that e by L as a constant terms out of the integral. E power r by L t is e power r by L t by r by L. You know the integral value of e power 4x is e power 4x by 4. Like that, constant value e power r by L t by r by L, this is your integration value plus c. This L cancel, you will get e by r. Next, you will get in this step, you will get e by r. E by r, e power r by L t plus c. Here you will get e power I into e power r by L t. Now you divide throughout by e power r by L t, both sides, you will get I equal to e by r into e power r by L t by e power r by L t cancel, you will get plus c into e power r by L t becomes e power minus r by L into t. This e power r by L t becomes e power c into e power minus r by L into t. Now, what is our requirement? Find out the current I when when time t, electromotive force is 0. We have to find out the current I when E is 0. Here instead of E, if you substitute 0, I equal to C e power minus r by t. That's your answer. That's all. Final step, you will get the answer only. See, the required current I when the electromotive force is 0. Our problem, in this equation, you substitute E equal to 0. So the required current, therefore, the current I, therefore, the current I when E equal to 0 is, this is 0. E is 0, C e power minus r by L t, this becomes 0, I equal to C into e power minus r by L t. This is our required current. That's all about the problem. C into e power minus r by L t. Okay, this is our problem. So, this is the problem using linear differential equation, the application problem. Okay, so I'll stop here and I will continue the remaining topic in the next video. Thank you.